Action. Well, good morning, geometry students. Welcome to our Learning at Home Week 7. We are in a little bit of a different venue today, and I'll explain why in a little bit. But I hope you're doing well. I hope that you will get something out of these videos, and we'll work this week on volume of three-dimensional figures. The reason we're in the bathtub is because one of the real famous people who worked with volume is Archimedes, and whether the story is true or not, the legend is that Archimedes had a big breakthrough in working with the volume of irregular figures in his tub. So in honor of Archimedes, we're going to work in here today, although our work is going to be focused on regular figures, kind of your standards. So we're going to work through the problems that are found in the Google slide presentation that is shared with you. I'm going to sketch them up here, but you can look at them on your screen and make sure that you understand what's going on. Alright, so we're going to dive in here. The first thing that we're going to look at are cylinders. Cylinders are basically two circles that are connected into a three-dimensional shape. So I'm going to draw my cylinder, and I'm going to draw what would be my circle. Sketch down, and then the lower half of my circle, and we do this dashed line to show what we would not see three-dimensionally. Now, in the problem you're looking at, we have this diameter of 4 feet, and we have a height of 6 feet. Now, one of the key things as I look at my formula sheet, and I shared this with you, so you have it as well, the volume of a cylinder is pi r squared h. Now, the r in that problem is for radius. When we're given the diameter, we need to alter that so that the radius is actually 2 feet. Okay. But the formulas, and as with area of figures that we looked at, if you know the formula, it's pretty easy to fill in. So volume equals pi, and we're going to use that either pi button on your calculator or 3.14, either one is fine, times the radius, which is 2 feet, squared, times the height of the figure. And really what this would do is it would take the area of the circle and just stack it up three-dimensionally. So pi r squared is the area of the circle, times the height is how tall it is. Okay. So some quick math there. Pi times 2 squared is 4, times 6 is 24, and I will get my calculator out. 24 times pi is going to be approximately 75.40, and then we're going to use feet cubed, or cubic feet, whichever you would prefer there, because it is three-dimensional, so we have that exponent of 3. Okay. So again, volume equals pi times r squared times h. Sound good? Alright, on to the next one. Hold on, I gotta erase here. Kind of hoping that this works, because I didn't really try it yet. So we'll maybe have a little bit of residue. Shh, don't tell my wife. Alright. The next one we're going to look at is a cone. When I think cone, I imagine ice cream cone. The picture that we have here is what would be an upside down ice cream cone. But cones take that same circular base. Imagine your parking cone, okay, or things like that. Okay. In our diagram, okay, we're given this radius of 10, now we're looking at centimeters, so a little bit smaller. And you see this line, dashed line, drawn down the middle. That's the height of the cone from the point. Okay, we don't want to take it at a diagonal. The reason you see a 90-degree angle there is because we want to measure that height straight down. Okay, and that height, it tells us, is 24 centimeters. I check my formula sheet, because I don't need to have these formulas memorized. I have the formula sheet. And it's almost identical to that of a cylinder, except you see this 1/3 out in front. Volume equals 1/3 times pi times r squared times h. Okay, really the idea that I could take 3 of these cones and fit them inside of a cylinder with the same base and same height. I know my height, I know my radius here, so I can leave it at that. Volume equals 1/3 times pi times 10 squared times 24. Okay. So we worked through that, and if you're really good at it, you just put it in your calculator all at once. So 1/3 times pi times 10 squared times 24, and that is going to give me a large looking number. My volume is 2,513.27 cubic centimeters. Right. So again, cones, 1/3 pi r squared h is our formula there. Okay. Cool, I'm going to erase that. Alright, and our last shape in this video is going to be a shape with a curve. Okay, we're going to talk about a sphere now, and spheres are kind of fun to draw. Okay, we just draw our circle, and then we kind of make that eye like you learn about in art class, although don't tell your art teachers that this is my eye, because it's not real good. Okay. There's really only one measurement with spheres. Spheres are all points that are equidistant from the center, but in 3 dimensions. Okay. And we're told in this problem that this one has a a radius of 8 inches. Okay, so perhaps a beach ball of sorts, if you will. Okay. The formula for spheres, I check my formula sheet, and it tells me to use 4/3 pi r cubed. Okay, and that's one of the big notes here, because we're in that 3rd dimension. We're not just talking about a circle anymore. We're going to use that 3rd power. Okay. And don't forget you have that fraction of 4/3 there. But if you have the radius, it's easy to fill in. If you're given the diameter, make sure you cut that in half. So volume equals 4/3 times pi times 8 to the 3rd power. Okay, so I'm going to go to my calculator. Now I'm going to figure out what 8 to the 3rd power is first. It gives me 512 times pi times 4/3, and that's going to give me my volume of 2,144.66 cubic inches. And I'm going to round that off. Remember that when you're typing fractions in the calculator, I can just type 4 divided by 3, order of operations will work it out. And I can use the pi button, or you can use that 3.14. So those are our 3 solids that have curves to them. We had cylinders, we had cones, and we had spheres. All right, we're going to stop this video. We'll shoot another one here with non-curved figures. But first I got to go find a cleaner so I can clean this shower wall off before I get in trouble. See you later.